handling remote access issues. In this nugget, we're going to learn how to troubleshoot remote access from the eyes of the desktop support technician. We're going to lead off with a discussion of the remote access connection methods that are supported by Microsoft Windows Server 2008. Yet again, as if I haven't told you this enough, although you in your real-life experience as DSTs and systems engineers may be accustomed to using, say, Cisco or other third-party solutions to handle remote access in VPN, we need to always bring ourselves back to the technologies offered by Microsoft itself. We'll then look at access, authentication, security. We'll review a lot of those remote access and VPN protocols, some of which do in fact bleed over and are considered industry standard protocols. Some are Microsoft-centric technologies. And then third, we'll look at practical steps for troubleshooting client-side connectivity. Let's get started. Fortunately, Microsoft has always kept remote access on the front burner, so to speak, in their server and desktop operating system products because they know what is really the case in business, where you have your protected corporate local area network, then you have a firewalled connection to the internet, and then you have remote employees who may be working out of their homes. You might have traveling employees who need to connect back to the corporate LAN through their hotel rooms, or maybe a Panera Bread, a coffee shop, an airport, etc. And the idea is we want to give these remote folks the local area network experience. In other words, being able to see the same servers in the network control panel list that you would see if you were physically on campus. Of course, there's the routine stuff like being able to access email services. And I know what you're thinking. Yes, most email server packages, for instance, Microsoft Exchange Server, gives you web-based access to email in the form of Outlook Web Access. But more particularly, there may be line of business applications inside the network, or maybe you want to support RDP, Remote Desktop Protocol, so that you as an administrator can tap into your server desktops remotely. These are all common scenarios for remote access. And the idea, again, is to give the user an authentic local access experience remotely, while at the same time not sacrificing security. Again, there's yet that counterbalance. So many of these seesaw counterbalances in information technology, where we have security pulling on one side of the tug-of-war rope, and fidelity of user experience on the other side. All right, on the prehistoric side of the fence, in terms of connection methods, I'm actually going to change this to remote access instead of VPN. We have the old school traditional dial-up. Now, this is obviously going to be a worst-case scenario for offering remote access services, especially in 2010. You're capped, at least in the United States, with approximately 56 kilobit per second speed, unless you take advantage of a technology Microsoft has offered for many, many years called multi-link. But that would involve, say, two modems simultaneously installed and configured on the remote user's box, and then two modem connections on the remote access server on the corporate side of the fence. That can get really expensive to have to dedicate those modem interfaces, especially if you're pairing them to increase throughput. Nonetheless, Windows Server 2008 Network Policy Server and Remote Access Services still offers dial-up, and there's some rudimentary, very rudimentary security built into this. For instance, you can configure callback, where the server will disconnect the initial call from the user and then place a call back to the user. That gives you the security of knowing that the client's call or the user's call originated from a specific number, and it also just as commonly is used to bypass long-distance charges. So that's dial-up. The traditional protocol we use to encapsulate those LAN packets is the point-to-point protocol, or PPP. Whenever you're doing a remote access connection, you wind up taking data frames, also called data packets, that exist and are sourced and have destination on the local area network, and we encapsulate those LAN frames in a more robust envelope, as it were. The PPP envelopes I've always considered to be pretty tough, almost like mini tanks or troop transports. When you think of what a rough passage it is using traditional analog and digital telco lines, you'd have to think, wow, it's a miracle that you can get any LAN traffic to and from a remote user. Dollars to donuts, your business is offering remote access through what's called a virtual private network, or VPN. There's two types of VPN. Actually, I'll just say two general categories in Microsoft Windows VPN technology. We'll talk about each of these in more detail in just a moment. Traditional VPNs are ones that use tunneling protocols like point-to-point tunneling protocol, Layer 2 tunneling protocol, etc. What's brand new now in Windows Server 2008 R2 and Windows 7 is this technology called direct access. Again, we'll talk more about this in just a moment. The entry requirements for implementing direct access VPN are high. On the server side, you need a Windows Server 2008 R2 remote access server, and on the desktop side, only the Ultimate and Enterprise editions of Windows 7 understand direct access. In a nutshell, direct access is a transparent IPv6 method to connect clients to their corporate LAN, like you see down at the bottom. What happens with a traditional VPN connection is that the user on their client machine is working remotely, like I said, whether it's at home or in an airport, whatever. And the first of the two stages of a traditional VPN connection is that the user makes an internet link. Now, that could be at home through their internet service provider or piggybacking on maybe using a Sprint card or some kind of PC card-based internet connection. However you're doing that, you first need a connection to the internet. And obviously that represents a jungle, so to speak, a jungle of possible dangers, hazards, men in the middle capturing data packets and trying to decode them, etc. So the VPN comes in as a second connection that piggybacks on top of the first. First, we create a secure bridge or tunnel that links the client computer with the corporate network. And that bridge protocol can be point-to-point tunneling protocol or layer 2 tunneling protocol, for instance. Once you have that tunnel built, you then have a mechanism, kind of a bridge, to get your LAN packets to and from the client computer. Of course, in order to provide confidentiality, integrity, and authentication, we also need an encryption protocol. And there's a variety of those, we'll talk about those momentarily, that protects and gives confidentiality, integrity, and authentication, to repeat what I just said, along that channel. Now, once that happens, once the VPN is actually up and the user is authenticated, they can issue universal naming convention paths from the run prompt to hit servers. They can open up their web browser and hit line of business web applications that exist only in the corporate LAN. The idea is they have a slightly slower, sometimes significantly slower link to the corporate network, but the link is there nonetheless and it offers security. You should also know that based on this encapsulation of different protocols, again, at the simplest level, you have these outer protocols that are made use of, protocols like L2TP and IPsec, that are providing an armor coating, so to speak, of those data frames as they traverse the VPN. Inside those protected envelopes, you have your actual second stream of traffic, and these are the data packets that work on the internal network. So in other words, you would have in the outside IP address header the public IP address of your machine, or if you're in an airport or a home network, you're using some kind of private IP addressing scheme to get out onto the internet, you'd have that set of IP addresses exposed. The destination address, of course, would be the port on your remote access gateway at your client office. Once the remote access gateway receives those protected packets, it strips away the outer layer, exposes the internal packet, and there the source and destination IP addresses are going to be understood by the corporate network. To finish this whiteboard out, take a look at this last acronym, CMAK, also called CMAC. This stands for Connection Manager Administration Kit. It's been around for a long time, and it used to be available as a separate download only. Now in Windows Server 2008 R2, you can install this as a feature. And basically, this simplifies the process of deploying client-side VPN profiles. Again, there's the idea, if you have a whole fleet of sales users with laptops who are going to need VPN access, you can either set up each machine individually, stepping through the same steps, pointing those client machines to the network policy server, or for instance, you can create a single profile in CMAC and then distribute that profile en masse to all of your client computers. It's a nice way to do business, and I'll give you an introduction to it in the upcoming demo. Now, what do you need to know about traditional VPN connections for the 7685 exam? We certainly don't need to go into the degree of depth that's required for you to take a Windows Server 2008 network infrastructure exam. However, you do need to be able to recognize the following batch of protocols. First, we have not a protocol, but an information security methodology to which I've referred earlier in the course. That's CIA, where C deals with data encryption, confidentiality of data. I deals with integrity, or making sure that packets that emit from the source computer are exactly the same packets that are received by the destination computer. And A refers to authentication. This is one-way or two-way authentication. One way, where the client challenges the server, are you who you say you are? Two-way being the server also challenges the client with the same question. Now, of these remote access, and in particular VPN tunnels, PPTP, L2TP, SSTP, and IKE v2, only PPTP, the point-to-point tunneling protocol, has the infamy or unfortunate distinction of offering only data confidentiality but no authentication or integrity. Now you might think, well, why does Microsoft even offer this as a VPN tunnel type if it's only giving data confidentiality and nothing more? The reason for that, at least the generally acceptable reason, is that PPTP is the easiest of these VPN tunneling protocols to set up, chiefly because you don't need to worry about public key infrastructure, or PKI. PKI and its associate in Windows Server 2008, Active Directory Certificate Services, has come up several times earlier in the training. So at this point, because I assume you've been watching these nuggets sequentially, you understand the mechanics of digital certificates, at least at a basic level, and you understand why they're important for ensuring integrity and authentication. Regardless, you need to know that with PPTP, we have MPPE. I'm saying P an awful lot, aren't I? It's just all this point-to-point terminology tends to crop up again and again. Microsoft point-to-point encryption. This is the protocol that's used with PPTP to actually do the confidentiality or encryption of data packets. On the other side, we have to select, when we set up a PPTP tunnel, which protocol or protocols we'll select for authentication. Now, the best case scenario is you know what's going on the server side, on the VPN server side, and you're also responsible for setting up the client connection. Now, there's always going to be some negotiation that takes place. Well, I'm not going to say always, but sometimes, especially if you're enabling more than one authentication protocol, there needs to be some handshaking or negotiation between the client who's attempting to connect and the server that's receiving the connection. For instance, what would happen if you had password authentication protocol, which is a clear text authentication protocol enabled, and also MS-CHAP v2, if you had those protocols enabled in both the client profile and the server profile? Well, fortunately, the client and the server will always agree on the protocol that offers the highest degree of protection. So in this case, MS-CHAP would win out. The question then comes up, why would you then specify more than one protocol? Well, there's some different reasons for that. One is if you have different operating systems for your clients. Some versions of Windows don't support MS-CHAP v2. Admittedly, we're going back several years, but it's a possibility. That's chiefly it. You would have more than one authentication protocol as a means of backup to support down-level or different operating systems. Alright, next on our traditional VPN walkthrough, we have the L2TP tunnel. This is harder to set up, but a really great combination. You tend to see this as the default tunnel type for third parties, say Cisco VPNs. PPTP is a Microsoft proprietary protocol, whereas L2TP and PPTP are out in the open. Therefore, there's much wider adoption and support of these protocols in the public. Actually, that's another reason why you want to be selective in not only your tunneling and encryption protocols, but also your authentication protocols. Remember, for the 7685 exam, we always assume that our remote access server, our VPN endpoint, is a multi-homed Windows Server 2008 box, even if that's not what you normally see in business, quite frankly. In business, you might have a Cisco VPN server that supports only such and so authentication and tunneling protocols and encryption protocols, so that would obviously guide what you have on the client side as well. Now, the L2TP tunnel provides all three of these elements. It uses digital certificates for authentication, integrity, and all that, so it's a really nice, robust way to go. But but is going to require that you have an Active Directory certificate server up and running and that all your computers have digital certificates. A neat thing also about these tunnels, not only L2TP but also IKE, which we haven't yet discussed, is that when you're using digital certificates, it opens you up to using the EAP protocol suite, Extensible Authentication Protocol. Extensible because there's more variety. Instead of the traditional challenge of username, password, domain name, EAP with digital certificates allows you to start using multi-factor authentication types like smart cards, if you've ever heard of or seen those. So remember that for your exam too. SSTP, this stands for Secure Socket Tunneling Protocol. It works and functions with point-to-point protocol and L2TP. It functions with several other protocols, but its chief claim to fame, and the reason why it's so compelling to some businesses, is that it obviates or removes the need for advanced firewall configuration. Advanced firewall configuration is almost always a stumbling block when you set up a VPN, because think of it this way. You have the LAN on one side, and then you have your firewall protecting incoming and outgoing traffic to the net. Some of these protocol types don't play particularly well with NAT devices, for instance, which are also typically enabled on a perimeter device. NAT would involve having to strip the packets to get to source and destination addresses, which defeats protocols like Internet Protocol Security. As a matter of fact, I just noticed a typo that I'm going to correct right now. L2TP works not with point-to-point tunneling protocol. You probably noticed this glitch earlier, and if you did, a hearty congratulations to you. L2TP is the tunneling protocol that functions with the industry standard IPsec protocol. There we go. Remember, PPTP is tunneling only. IPsec is an encryption protocol that functions with L2TP tunnels. Regardless, getting back to our regularly scheduled programming, SSTP is awesome because you don't have to worry about all of these firewall rules. SSTP is a way to create a secure VPN tunnel that operates over, you guessed it, HTTPS, or Secure Sockets Layer over HTTP. And you should know by now that whereas unencrypted HTTP functions on TCP port 80, SSL HTTP functions on TCP 443. And frankly, your business would be nuts to block traffic on the SSL port. So that's the big claim to fame for Secure Socket Tunneling Protocol. It makes it easier yet for a business to deploy a VPN server by creating and managing VPN tunnels over HTTPS. Finally, we have IKE, Internet Key Exchange version 2. This protocol is new in Windows Server 2008 R2. Its big claim to fame, it uses again IPsec, traditional tunneling, and encryption protocols. The thing you need to remember for your exam is that IKE v2 enables another new feature called VPN Reconnect. Now this is a really handy feature because how many times have you in your lives using VPN client technology been doing a file transfer or some other business and all of a sudden the VPN link just goes kaput. It's happened to me a lot and it's really frustrating. You then have to, worst case scenario, reboot the computer, but at the very least reestablish your VPN session and then start your work over. If you're using IKE v2 and integrating it with, say, an L2TP IPsec tunnel, VPN Reconnect will automatically and transparently pick up a lost VPN connection. If I haven't already said so, here it is, that IKE v2 has a steep entry requirement inasmuch as your client computers have to be Windows 7 and your server computer has to be running Windows Server 2008 R2 and be functioning as the VPN gateway. Direct access. Thus far, we've been talking about server-side VPN setup, and we've spent not too much time yet on the client side of things. Now, all this discussion of server-side setup, I believe, is important because when you're troubleshooting a client-side issue as a desktop support technician, if the server side of the equation is just blank, a black box, then you're at a severe disadvantage on making changes on the client side and really understand what's going on under the hood. Now, direct access is meant to address the complexity of VPN setup and maintenance, and I believe Microsoft intends direct access to replace the traditional VPN links in terms of Windows VPN access. Direct access is an always-on IPv6-based IPsec VPN, and you remember the glitch I made in the previous slide. IPsec is an encryption protocol. It's actually a lot more. You can create entire VPN tunnels using nothing but IPsec. It's a wonderful, wonderful protocol family. family. IPsec is used with direct access to create these seamless VPN tunnels. And it's nice for many reasons, one of which is the user doesn't even need to necessarily know what it is or how to start it. Because it's always on, there's actually nothing started as such. Number two, from a systems administration standpoint, it allows us to solve some problems that you normally have in a domain environment, such that while the user's laptop is connected to the domain directly, they can receive their group policy updates, their Windows updates, all that. When they're away from the domain, even over a VPN tunnel, sometimes these bidirectional server updates can fail. Direct access, like I said, will, as long as the user is connected to the internet, transparently create a secure IPsec tunnel to the corporate network, and therefore the client is still protected with group policies. You can offer RDP or remote desktop protocol seamlessly to the user, and then there's this whole other protocol suite or functionality suite, to be more technical about it, called Network Access Protection. Network Access Protection, or NAP, offers various ways to deploy health policies on a network. For instance, a user, in this case a direct access client, would be working from home or whatever. Under the hood, they have a direct access link to their LAN. NAP would ensure that the client computer has, for instance, Windows Firewall turned on, an antivirus installed, current updates for that antivirus, Windows Update turned on, current with Windows Update. It basically ensures, it remediates against computers falling out of compliance with your computer health policies. It's a great technology. With respect to the protocol stack that underlies direct access, how do you do this? How does this actually work? Well, the best way to implement direct access is to have a fully functional IPv6 infrastructure. Now, the idea of giving all of your remote users a public IPv4 address is ludicrous because we've simply expended most of that address space. Public IP addresses that are globally unique are very rare. Typically, you're only going to have a few of those at the perimeter of your network on, for instance, say, your VPN gateway. Well, IPv6, being a 128-bit address space, is so huge that it's easy, as a matter of fact, to give globally unique public IPv6 addresses out to your client computers. And so, therefore, a user can be, theoretically and in actuality, anywhere in the world and use his or her public IP address to get all the way through the tangled web of the internet to the VPN gateway at the corporate site. And that's the first method that a direct access client will use to make that connection. Now, if that fails, if you're like most businesses who haven't yet rolled out production IPv6, the next step is for the direct access to try to tunnel the IPv6 traffic over an IPv4 backbone. The two main implementations of these transition technologies are called Teredo and 6to4. If that fails, the third way, and you notice Microsoft is very insistent here, they want to make sure that this direct access link will work. The client computer will attempt to package those frames, those IPv6 frames, and transmit them over HTTPS. I mentioned earlier when I first told you about direct access that the entry requirements are steep. You pretty much have to be right on the cutting edge. Like I said, best case having production IPv6 infrastructure, and also your desktop computers can only be running Enterprise or Ultimate Edition Windows 7, your servers running Windows Server 2008 Release 2. And then to answer the question, how do clients get configured for direct access? That's actually done through group policy administration. VPN troubleshooting tools. As a desktop support technician, your task is going to be, more often than not, to help the user on the client side of the VPN connection establish a connection to the corporate VPN server and make sure that that doesn't fail. Some of the more common first-party troubleshooting tools we've already looked at. IPconfig to verify which IP addresses the client is using. Now you'll notice I said addresses. Remember that in a remote access scenario, in particular with VPNs, we have data packet encapsulation, where there's going to need to be a public set of IP addresses to get those frames from the client computer to the corporate network, and then we strip away that envelope, and then we have a second frame with source and destination IP addresses that are applicable to the local network. Of course, ping and traceroute are our friends for validating connectivity and looking at the detailed path that those packets take from source to destination. Netstat is used to give us an idea of what protocol ports are in use. Again, this is helpful because each of those aforementioned VPN protocols is associated with one or more TCP and/or UDP protocol ports. Network Shell is our Swiss Army knife for command line TCP/IP configuration. Also has a functionality in VPN as well. Microsoft has significantly revamped Network Monitor over the past few years. Version 3 you can download from Microsoft.com, and it's an excellent way to really get down low. Fire this up on the VPN server and/or the client side, and you can actually visualize and characterize data packets on a packet-by-packet basis for troubleshooting purposes. And then, of course, we have good old Event Viewer and event log data. In our demonstration, I'm going to show you the rudiments of the server-side setup with VPN. We'll also go on some side trails. For instance, I'll show you Connection Manager Administration Kit. The lion's share of the demo, though, will look at the VPN client, how to set up these remote access connections, as well as troubleshoot them. We're going to begin our demo on VPN troubleshooting on the domain controller, which is doubling as our remote access server. You see we're in Server Manager right now. Actually, let me minimize this to come back to the desktop, and let's go to Network Properties and view our adapter settings. Now, I've mentioned this before in passing. I want to mention it explicitly now. If or when we're going to use a Windows Server 2008 machine as a router, as a VPN gateway, etc., in particular a router, we want that server to be multi-homed. And what that means in Microsoft parlance is that that server has at least 2 separate physical network interface cards. Now, the idea is we have one card that's connected to the local network, the other one that's connected to your internet service provider, let's say. So if you didn't already know that Windows Server 2008 can function as an IP router and as a NAT device and all of that, well, you certainly know now. Now then, the first thing I want to show you is that Connection Manager Administration Kit that makes it easy to deploy remote access connections to your users. In Windows Server 2008 Server Manager, you can go into the Add Features wizard and just follow the steps. You'll see I've already got it installed, Connection Manager Administration Kit. And once it's installed, you can open it up directly from Administration Tools, or if it's recently used, right off the Start menu. It's really easy to use this tool. It is a wizard, as you see here. I'm not going to step through the whole thing because I've actually already created a policy profile, but I'll get you started anyway. First, we choose who is our target operating system. Are we creating connections for Windows 7 or Windows Vista? Well, I am. Are we going to modify an existing profile or create a new one? You see I've created one called NL2VPN. I'm going to choose New Profile here. A lot of this deals with customization and branding, quite frankly. It's not a lot of work to create a client-side VPN connectoid. You pretty much just need to specify the target VPN server's IP address or host name and make sure you've selected the correct protocols. So you're going to find that in the Connection Manager Admin Wizard, a lot of this deals with branding. So we could call this Corp VPN, and I'll call the file name Corp VPN as well. Again, we have the opportunity to merge information from already existing profiles. I'm not going to do that. Here's where we can specify a phone book entry to point the client to a VPN server. In my case, the VPN server is at 10zip10. Use the same username and password for VPN and dial-up if you're going to create a phone book with multiple profiles, say one dial-up and one VPN. You can actually synchronize the user's phone book to download updates from the server, configure and customize entries. You can customize the routing table or add route entries to the client-side routing table each time they connect. Proxy is important because we don't want our users to establish a VPN tunnel to us and then go out onto the web through the VPN pipe and go to sites that are unapproved by the company. So we'll want to make sure in most cases if you're using, say, a specific discrete proxy server and not a transparent one, that we configure that right here. We can do custom actions, and then we get into more specific branding. Are we going to use a custom graphic that contains our corporate logo, etc., phone book bitmap, icons, and so on? At this point, I'm going to quit the wizard because I think you have the idea. At the end of the process, what you have is, if I can and go into my shared folder, a small collection of files. There's an executable file, weighs in, it looks like at 1/4 of a meg, and then some support files. And this is what actually is going to be deployed to the client. We can use group policy software installation, or in this case, I'm actually going to manually invoke the installer on the client box. Next thing I want to show you is in group policy, you can navigate to user configuration, policies, administrative templates, network connections, and there's a lot of policy here that enables us to tweak, tune, customize, and restrict the remote access connection stuff on the client side. For instance, prohibit deletion of remote access connections. I mean, some of this stuff you might think, isn't this kind of control freaky? But actually not. What you're going to do as a practical benefit of restricting what users can do with their connections is you're going to reduce your support costs, because a user, maybe not maliciously, but just through incompetence, and I mean that in the best sense of the word, may delete a remote access connection if you let them. And that's just going to give them connection problems and result in an extra support ticket, you see? So this node in the group policy editor deals with not only your remote access connectoids, but also what users can do on their LAN connections as well. So I wanted you to be aware of this. Next, I wanted to show you the routing and remote access console. If you've done work in Windows Server 2008 prior to watching this nugget, in particular Windows Server 2003, this should look very familiar to you. What I did in order to get the remote access server up on this machine is I added it as a role. Now, it doesn't come in, when I say it, I mean routing and remote access, under that name. What I actually installed was what's called Network Policy and Access Services. We can actually drill into there and see what's going on by, let me right click and choose Add Role Services, and this will actually drill into that role and enable us to manage the subcomponents of it. I want to show you exactly what I installed. To set this server up as a VPN endpoint, I simply installed Routing and Remote Access Services, and by doing that it gave us both the remote access service and routing. I technically don't need routing in this case. I'm not multi-homed, but I brought it in anyway. If you're going to make use of network access protection, or NAP, you'd need to enable the network policy server, and then if you really want to go to town and deploy this with health policies, you've got health registration and host credential authentication support as well. That's beyond our scope though. We don't need to worry about that. Back to routing and remote access. The first time you run through, you specify what protocols you want to support. I simply did a custom setup and specified I wanted to do VPN. So what we see here in the ports node under the server is, well, a huge number of what are called mini ports. You have to think of it this way. In old school land with remote access, let's say dial-up support, you're going to have a physical modem interface for each line or each connection. When you're doing VPNs, it's all virtual connections, isn't it? You're not going to have a separate Ethernet interface for each incoming VPN connection. That's silly. So by default, Microsoft is giving us a number, I believe it's 128, virtual ports for each protocol that we're enabling. Now we can customize this by right-clicking the ports, coming to Properties, and here we see the Secure Socket Protocol, Point-to-Point Tunneling Protocol, L2TP, and IKE. So if you want to configure those, for instance PPTP, we can double left click it or select it and click Configure, and each one has slightly different options, and you can tweak the number of virtual ports for each one of these. The final thing I want to show you in the Routing and Remote Access console is where we can specify our VPN protocols. We'll right click the server, come down to Properties. The General page allows us to turn on or off the routing functionality. Again, in a silly way, I'm not multi-homed, I have IPv4 router enabled. In particular though, for our purposes, I'll specify we're an IPv4 and an IPv6 remote access server. On the security page, this is where the rubber meets the road. For authentication provider, you can choose Windows Authentication, which is going to pass the user's domain credentials to a domain controller, or you can use Radius, and Radius is a way to centralize authentication. This is especially helpful if, for instance, you have an integration between, say, Windows Server 2008 remote access servers and third-party ones. Also, Radius is an excellent way, even if you just have only Windows Server 2008 VPN servers, to centralize protocol policy management. In our simple case though, we're just going to do Windows Authentication, and if we click Authentication Methods, notice that we can select more than one protocol. Now for security, if you know exactly what your clients are and know what your server supports, I would recommend you choose one or maybe two of these protocols, keeping in mind security. For instance, PAP is an unencrypted password. The other ones do offer encryption at various levels. I know we don't have Active Directory certificate services, so I'm going to deselect IKE v2, and there's optionally unauthenticated access. It's nice that Microsoft gives us that for troubleshooting, but we're certainly not going to want to do that otherwise. If we're going to do an L2TP connection, we can do it via just a very basic pre-shared key routine. I'm going to put in a pre-shared key, a very simple one of password. IPv4, we can determine how our IP address is being assigned to connected users. Now, of course, we would need to have DHCP up and running in order to pass through to DHCP. Otherwise, we can create a static address pool, which I'll do right now. I'll just have a 5 address pool. Do the same for IPv6. Are we allowing IPv6? IKE v2, PPP, especially if we're doing dial-up, are we going to allow multi-link and compression? What kind of logging do we want? Good deal. So at this point, why don't we switch over to our Windows 7 client and set up the client-side connection and do some troubleshooting. Now let's have a look at VPN client-side setup. I'm on WinNugget, domain member Windows 7 Ultimate Edition PC. We're going to open up the Network and Sharing Center, and what we're going to select is under Change Your Networking Settings, we're going to choose Set Up a New Connection or Network. This is the wizard-based approach. We're going to run through setting up a profile manually, then we're going to install the one that we created or I created in CMAC earlier. Note that we can connect to the internet, set up a new network, connect to a workplace, set up a dial-up connection. Well, this one says VPN. This is the one we need. How do you want to connect? Do you want to use your existing VPN connection or dial directly? Notice it gives us some example text here in light text for the internet address. We can add a fully qualified domain name, an IPv4 address, or an IPv6 address. I'm going to put the IPv4 address of my server. Destination name, we'll just call it Nugget Lab VPN. We're not going to use a smart card. We could allow not just the currently logged on user trainer, but other folks to use this connection. You'll notice this is an elevated command. I won't do that though. What are our connection credentials? I'll fill that in with username, password. We'll say remember the password. The domain is Nugget Lab 2. And now we're all set. To make that connection now, assuming that we first have an internet connection established, we can then revisit Network and Sharing Center and this time choose Connect to a Network. This is a very different motif than what you've seen in previous versions of Windows. We see a little notification pop up from the notification area that gives us a nice link to the VPN connectoid that we created. Give it a click, click Connect. The trainer account, we've stored our password, we have our domain. Is this just going to be me or another user? But before we click Connect, we're troubleshooting now. We want to try to fix things on the front end. Let's click Properties and verify what we're doing as far as protocols are concerned. You notice that the initial run through the wizard didn't ask us any of that stuff. This is a common point of VPN failure. Options, nothing particularly important there. Our big deal is security. And the reason why that wizard didn't ask us is that the type of VPN is set to automatic. So remember earlier I mentioned that the VPN client and the VPN server will go through a negotiation process? Well, that's what I meant. That negotiation process also includes the tunnel type used. So in the list you can specifically choose one of the 4 that we reviewed: point-to-point tunneling protocol, L2TP with IPsec, Secure Socket Tunneling Protocol, or IKE v2. I'm going to leave that at automatic. For data encryption, you can customize this. Now, remember earlier I also showed you group policy. You can customize things there as well. You can be more lax, optional encryption. For advanced settings, remember we used a pre-shared key for L2TP? Well, this is where you'd put that in on the client side if you wanted to do that. IKE v2 tab is cool because this mobility switch enables you to turn on or off that VPN reconnect that we talked about earlier in the course. And note that you can actually do a reconnect after an outage of up to 8 hours. That's pretty reasonable in my opinion. Down below we have authentication, and we can use either traditional line protocols or connection protocols, or we can use EAP. Remember, if we use EAP, we can use digital certificates, we can use smart cards, variety of different extensible authentication methods. I'm going to just use your traditional protocols. We can do PAP, that's unencrypted, CHAP, MS CHAP v2. remember that the protocol handshake is going to agree. That is, when I say agree, I mean the client and the server will agree on the most secure protocol there. When I clicked networking to navigate to the next page, it says the protocols you have selected include PAP and/or CHAP. If one of these is negotiated, data encryption will not occur. Do you want to keep it? Well, I'm glad it told us that. So let's just keep the CHAP protocols and keep PAP out of the picture. Networking allows us to install additional components or check out what's going on as far as Internet Protocol v4 and v6 on the inside or inner packets of the VPN tunnel. That should look pretty familiar to you. Alrighty then, guess it's time to connect. The second way we're going to create a connectoid is through Connection Manager Administration Kit, or CMAC. So on the client machine, I'm going to open up Run, as you saw here, and I'm going to hit up DC Nugget 2, and then that SharePoint that I manually created. And things come to a grinding halt. This is to be expected. In fact, I set this up intentionally because it points out another important troubleshooting and teaching moment. Let's take a look at this error that popped up when we attempted to install the CMAC profile. It tells us the version of this file is not compatible with the version of Windows you're running. Check your computer's system information to see whether you need a 32-bit or a 64-bit version of the program, and then contact the software publisher. This is a significant gotcha, friends. Let me come into Computer Properties to open the System Control Panel, and you'll notice that my machine, WinNugget, is running the 32-bit version of Windows 7. Youch. What happens is, if you're on a 64-bit version of Windows Server, for instance, Windows Server 2008 R2, which only comes in a 64-bit variety, then it's going to create profiles for 64-bit clients. In order to get this working, we're going to need to run CMAC on a computer that runs 32-bit Windows. Consequently, how do we address this conundrum? My one and only server is 64-bit and WinNugget is 32-bit. Are we not going to be able to create a CMAC profile? Well, it seems like Microsoft has thought about just about everything in these latest editions of Windows. As it happens, we can open our Windows Features dialog. I'm just typing Windows Feat in the search box to get Turn Windows Features on or off. This is requiring elevation to do. And you'll note that for once, I don't think you've seen this dialog earlier in the course, because actually I was logged on to WinNugget as an administrator. But this time around, I'm logged on as just an ordinary user account. So instead of being prompted for consent, I'm actually being prompted for credentials. So I'm going to need to put in the domain administrator credentials. And in the Windows feature list, we'll see RAS Connection Manager Administration Kit, or CMAC. So that's how to answer that problem of 32-bit versus 64-bit. We've seen the CMAC, so there's no need to go any further. To finish things up, we'll open up the Network and Sharing Center one more time. And you know that to connect to a network manually, we can use Connect to a Network, and they show up here. A Connection Manager Administration Kit profile, if that installation succeeded, would simply add another entry to this list you see. Now, if we right-click, we can look at the Connection dialog or the Properties dialog, but we can't delete this. Moreover, if we're using group policy to control what users can do with their connections, we might want to prevent users from deleting them anyway. If the user does have the ability to delete a profile, and or if you as an administrator are troubleshooting, what we can do is from the Sharing Center go into our adapter settings, which to me seems a little counterintuitive. But we see here not only our true wired and wireless LAN connections, but also any remote access / VPN connection profiles listed as well. The menu bar allows us to start the connection, rename it, or delete it, again, assuming that we're not being blocked from group policy. If we right-click, we can look at status, we can do a connect, delete, rename, and properties are all administrative options. Properties we've seen before, no big surprise there. And to delete, we'll just right-click and select delete from the shortcut menu. Handling remote access issues review. In this nugget, we began by looking at remote action connection methods that are supported by Microsoft servers and clients. In particular, we mentioned dial-up, traditional VPN, and then this latest and greatest direct access. We then turned to this alphabet soup of virtual private network protocols, access, authentication, security. I hope the take-home message from that for you is that we always need to have a compatible protocol suite on both the client and the server side. Otherwise, there's not going to be any VPN link of any kind. We finished by looking at troubleshooting client connectivity, shared some of the traditional TCP/IP troubleshooting protocols like ping, traceroute, etc., and how we can apply those in a real-life troubleshooting situation. I hope that this has been informative for you, and I'd like to thank you